Okay, let's start. Hello everyone, and welcome to join us here. Public cloud is one of the most important use cases of clouds, and it's a very big market. And we think OpenStack could be part of it. Thus, we will share the presentation about how did OpenStack for public cloud in recent releases, and what are still missing today. So first, allow me to introduce us. I'm Yikun Jiang, focused on OpenStack, Nova, and here is Liu Sheng. He has contributed to telemetry, but now mainly work on OpenLab project. And other guy, Zhenyu Zheng, he didn't come here today. Kevin Zheng, yeah. We are all from Huawei OpenStack Upstream team, focused on upstream contributions and the pre-research of the Huawei public cloud commercial product. So the presentation is divided into 4 parts. The first part is the uniqueness of a public cloud. We'll tell you what's the unique traits of a public cloud and what's the different features between public cloud and other clouds, like private clouds, from user, operator, and vendor perspective. Secondly, we are the benefit from the OpenStack. In this part, we will tell you what benefit can you get if you build a public cloud based on OpenStack. Next one is what OpenStack improved in recent release for public scenario. We will sum up the features that have been done in recent release that improved OpenStack for public scenario. At the last part, we will talking about what are still missing in OpenStack for public cloud. This part, we will share our Huawei Cloud true stories, including our attempts and practice. So let's start the first part, the uniqueness of public cloud. We will look into this as 3 different roles, as I mentioned, user, operator, and vendors. So what are public users so unique? This could be in different scale, ranging from the personal use VM setting up their own VPN, or in enterprise that have thousands of employees. They will be challenged for operators because they will have to find the optimized resource allocation plans for all those customers in different scale. And offering the better user experience will avoid resource fragmentation. And the user demands also varies. There could be thousands of service combinations, and they will want to them cheap, functional, and easy to use. This will be challenge for operators as they will have to design the maintain twins of services carefully. And also need to make every service cost effective to provide a suit price to their users. Another thing is different type of users will have different user experience preference. For example, the rookie user want it as simple as possible, but pros may want to have full control of their resources. This means the operator need to consider every details of their service UI, even a big page view or a tiny button. So in order to serve the unique users, the public cloud operator itself will also have unique traits. The operator will have the ability to handle huge number of users, as their user could be from all over the world. It could be challenged to operate the platform at this scale and capacity. Operator would have to consider the cost, availability, performance, security, and so on. And the second one, follow the trend. Yeah, the operator should also have the ability to follow the trend, both the technical and the commercial. Operators should be able to respond fast to market and release new attractive service rapidly to keep the old user and attract new users. The operators should also be supported flexible and fine-grained builds options for users. Users will be able to choose the most suitable way according their user case. For example, user could pay either metering or monthly, yearly. This will provide the best user experience. So in order to deal with the unique users and operators, the vendors should be the best, right? Let's say what kind of ability they should have. First, rapid development iteration. In order to fulfill the various requests from public users, and the operators request rapid service releases. The vendor have to be able to develop in small depth and rapid integration, and easy upgrade. Rapid development integration will lead to rapid upgrade. So vendors will have to provide a way to easy upgrades to help the operators releases the latest services. If not, it could be a nightmare for operators to upgrade. And the last one, the most important thing for public cloud is stability and performance. Running a public cloud normally means run it for every day, every hours, and every minute. High available for all the time is the commitment from vendor and operator to customer, as well as the high performance. So after analyzing the uniqueness of a public cloud user, operator and vendor, let's have a look on how can OpenStack fulfill those requests and what are benefits if you use OpenStack to build your public cloud. We will also look at it from the user, operator, and vendor perspective. So let's start first into the as users. The most obviously benefit from using OpenStack based on public cloud is interoperability and capability across all OpenStack-based clouds and the related technology and hardware device. In view of the fact that OpenStack is the hottest open source cloud platform, and there are over 600 supporting companies in both the software and the hardware area. User could choose the most suitable cloud platform, software stack, and hardware stack according to their needs with any change to their own products as long as it uses OpenStack APIs. So as I just mentioned, there are over 600 supporting companies for OpenStack that provide over 6,000 contributors. And thanks to all those contributors, OpenStack provided the tons of projects that users can choose from, ranging from basic services like computing and network storage to more advanced services like accelerator management service or function service chain. Users can also make combinations of those projects and build their own applications. Next slide, OpenStack also integrates with various peripheral ecological tools such as Kubernetes, Terraform, Cloud Foundry, and the number of supported tools are still growing. Users can easily adapt those public tools to OpenStack based on public cloud. So if I am an OpenStack operator, let's look from operator perspective. Similar to users, the operators also want a high degree of freedom. OpenStack could help them to avoid the vendor lock-in, hardware lock-in. The operators could choose the best vendor according to their budget and business model and target the customer without changing the high-level cloud architecture because of OpenStack APIs. So another things the operator would like is free technical support, continuous evolution, and faster iteration from the OpenStack community. All observed bugs will be fixed immediately by contributors from all over the world. This could save a lot of manpower, and the operator could focus on the operating the cloud and make their customer happier. It's similar for feature requests. Everyone can raise their request to community, and there will be always fair discussion in community for everyone. And the small one can grow together with the giants. One example is Unified Limited feature. It's raised by CERN lately and has been discussed across the community and being implemented now. So take one step further. Sometimes a single feature is not enough for customers. We might need a brand new service. Luckily, in an active community like OpenStack community, there are always a group of of people who follow the trend and repeatedly implementing hot service. Take acceleration management services Cyborg as an example. It only takes 6 months from idea to implementation. Finally, the vendor perspective. Aside from all those interesting services, OpenStack also provides common library and middlewares that everyone can use. Vendor can easily use libraries to incubate their own services and integrate with other OpenStack services seamlessly. So the plugin mechanism is commonly used in OpenStack service. Vendor can also easily add their own plugins to the existing service to accomplish the certain the certain features, and they can upgrade separately. So another gift from the community is a well-designed QA and CI system like Jenkins, Garrett, and Zoo. Vendors can borrow this technology to their develop process, including our product team. We use this communicate QA system to product our quality of our product, increasing the efficiency and the productive of the development. So let's go to the third part. How did OpenStack improve in recent release for public cloud scenarios? Okay, this is a table summarizes key improvements in recent release in core project. As known as showing the table, there are quite a lot of them, and it's improved in our perspective. I'm not going to cover all of them, but take some highlight one as an example. So first one is our Nova tag support feature. This resource can be tagged by attaching a set of strings to an instance according their own specific requirement. This is a magic way to add the label or classification to an instance. And with the tag filters, user can easily filter out their resources. Okay, the second one is placement. It makes all resources can be managed uniformly and provide a very useful and effective way to find which suitable resources can be used. The placement service has been involved in Nova instance scheduling since Okata release, and it is still improving with the help of placement. The scheduling efficiency and accuracy in large scale deployment has greatly improved. Okay, the last about Nova one is very, very, very important one. The CLV2 architecture. Another improvement help operators increase their cloud scale. It's an architecture that separates the whole cloud deployment into cells in order to overcome the bottleneck in centralized DB and message queuing. This is helpful for operators and to increase the deployment scale. But now it's only limited to Nova. And the last one, volume multi-attach, allows users to share volumes between multiple servers, such as a cluster application with two nodes, where one node is active and the other one is passive. When the active one goes down, the passive can be taken over quickly and has access to the data. So the public user can build high availability applications easily using multi-attach volume. So the last report is my welcome to my partner Shengliu to share their experience and our Huawei's true stories.
Okay, thanks. Okay, I will introduce the following parts to you. Although there are a lot of improvements in recent release, OpenStack still have some gaps between good and perfect. So allow me to share our true stories in running OpenStack-based public cloud and find out what are still missing. As you may know, Huawei has been involved with OpenStack for over 66 years, and it's now one of the platinum member of OpenStack Foundation, and we have successfully run 5 public clouds with our partners across the world. Cooperated with more than 2,000 companies, provided with over 60 solutions and more than 100 of services. So I guess our experience could be valuable to you. As a public cloud operators and vendor, the most important things for a successful public cloud is the scale. To be honest, there are some shortcomings in OpenStack's architecture for large-scale deployment, such as the database and the message queue, which could be the bottleneck. As mentioned earlier, the community is trying to solve this by introducing major factors like placement and CLV2. It solved the problem in some level, but it's still limited to only Nova. In all Huawei and partner public clouds, we used an architecture named Cascading. The Cascading OpenStack have the compatibility APIs as same as the normal OpenStack, and manage the source drivers also same as the standard OpenStack API. Okay, with the scale goes up, the user experience and the performance could become a serious problem. Have to say, there are a lot of things we can do in this area, as shown in left graph. When indexing a resource, we need to talk through from API layer, object layer, circle scheme, and finally to the database layer. But there have some shortage in every steps. In our clouds, we have performed some improvements and also contributed some of them to the community. For example, for now, not all the key APIs has the pagination functionality supported. We have added support for most of them, and which allow users to query data by more accurate filters. We have also removed some unreasonable join and pre-checked steps if you go through with the Nova query API process. It's not hard to find there are many tedious parameter validations, and some are redundant. which may designed for structure consistency but inefficient. We also do the specific query API optimization to solve the inefficient filtration problem, such as the API fuzzy query optimization. We have made the improvements of 90% speed up. We also use the net API interface to improve the inefficient database conversation. That is mainly because the current SQL commit design is no performance in some cases. And we have added more reasonable indexes, remove additional indexes based on our real database access frequency. Another side effect from the large scale and complex deployment is the abnormal resource in the system. For example, there could be often fake and invalidated records left in the system due to some reasons. But currently, there's no reasonable mechanism to discover those, and most of them can only to be handled by administrator manually. To deal with these problems, Huawei have developed a set of tools to perform fast abnormality discovery, a health check service that can discover the abnormality of the key data and the service status. And a data audit service that audits periodically on invalidated records. The complexity of upgrading an OpenStack deployment has become the painless point for a lot of operators for quite a long time. This is because there are many components, and when upgrading, the operators has a high technical threshold and cannot be completed quickly. Before upgrading, there is no relevant mechanism to do health check of the system, which extremely leads to the failure of the upgrade. Some functions need to be manually carried out by administrators, and this is even more challenging in public cloud scenario. And we should do all of this without interference to the customers. As a result, we come up with a powerful weapon, which can do upgrade by one click, and service will complete package distribution, pre-check, database upgrade, configuration modification, data cleanup, and all upgrade services support grayscale, business noseless, and rollback. That's all our try to improve the upgrade mechanism for OpenStack. Okay, besides above introduction, we have done some improvements, but there are still many unsolved problems. Following are four typical examples. Firstly, not all the components support grayscale business noseless upgrade, which almost is one of the standard of evaluating maturity of a cloud product. But now it still needs more improvements. Another, the tools of log analysis called chain analysis are important for operators to quickly locate the potential problems, which is missing and are imperfect in current OpenStack. For OpenStack deployment or adjustment, it requires the operator understanding plenty of configure options of various components. Even we can search in docs, it's still a big challenge to start quickly for operators. For end users, it is very important to give a response for requests in a short time. But in large-scale deployments, it's easy to be a bottleneck when a massive of requests come at the same time. Okay, that's all. Thank you. Any question?
What you mean when we implementing the private feature, we have some limitation or something?
You know, you have two ways of selling storage, right? Like the way you guys sell storage there. One is, of course, you simply you have no limitations and you charge for the IOPS that's being used in your storage system. The other one is, of course, that you limit the IOPS. So my question was that do you guys limit that? And if so, what are those limitations?
就是这件事情是不是有什么限制没？OpenStack. So our limitation, I think, is from the user and user case and our deployment scale. So I'm not sure.
It's okay. Yeah.
Sorry.
I'm just curious. So
Sorry.
if you don't have that, that's fine.
Maybe some QoS on storage speed.
Yes.
Yes, we have the maybe some level of the speed on storage, high speed and low speed. They have a limit on by QoS limitation, which the user will find the high speed, will have the high speed storage. So we don't have the unlimited storage.
Okay.
Thank you.
Have you considered reporting bugs against the performance issues in the database queries or upstreaming the index changes instead of making those changes internal? There's a slide about inefficient
Yeah.
indexing.
Yes. Yeah.
Yes.
Have bugs been reported?
Do you mean the query?
For example, the redundant join and irrational indexing. Has anybody reported bugs for those?
It's for example, in Nova and Neutron, all contribute this to Upstream, but someone is not generous maybe as a pred maintenance. So all generalized feature we contribute to the Upstream community.
How do you do rollbacks?
Rollbacks, we know most of service like all service in recent release, the OpenStack service remove the rollback in upgrade in array service, but we do the rollback first. We develop the rollback upgrade based on the migrate like the original OpenStack DB script. This is the first, and to say, I have to say there is many services need to consider the security of the rollback. So we have to analyze the array service in array upgrade version, and to process the mainly work on DB rollback. just use the original migrate tools.
So also, how do you handle situation when during upgrade when the VM migration doesn't complete?
Okay, live migrate.
Yes. What do you do when the live migration doesn't complete?
Before upgrade, we live migrate the VM from one to.
It doesn't. Live migration actually doesn't complete.
What?
What happens when live migration doesn't complete? If live migration stalls, if it doesn't complete.
哦，他说，我知道。
We may have some limitation before rollback. Some limitation of operations.
We have the maintenance mode.
Yes.
It's forbidden the manage operation, but the data layer is work. Only forbidden the manage operation.
On the next slide, can you go to the next slide?
Okay.
Oh, sorry, there was one about upgrades, and it said some services are still, it was something about apps. Some services are still difficult to upgrade or don't support seamless upgrades. Is there specific examples?
For example, this is audit service contains many script, and this service called this iris script pre-declare, like the sender fake volume. One script will collect the record from the OpenStack database, and then we'll also have another script to collect the script from Huawei device. And this is the first step, collect the data. And then just put it in a file. And the compare service will compare the invalidated record between the first OpenStack database file and the Huawei device file, and finally find the difference and invalidated record and report to the alarm, give a alarm report, also a guide to user to how to process this situation. So it's a little different from in Nova, we find it and hear it. It just gave a report to user because want to operators to process this record. So not automate.那等关系升级的时候热迁移。我感觉刚才你理解错他的问题了。没事，下面可以讨论。Yeah. 咱们下面就来调。So any question left? Okay, thanks.
Okay, thank you.
Thanks.